Noise is a powerful tool for creative coders. Today, let's explore using noise in a basic particle simulation. This is an encore presentation, and it's been remixed and remastered. I hope you enjoy. Also, check out my course, Learn 3JS Basics. Available now. Let's go.
We're going to write a simple particle emitter, not using any frameworks at all. It's going to look a little something like this. This is part of a two-part video. In the second video, we'll add noise to the particle path and the color as well to create this. Starting from here, here's our boilerplate. I'm going to grab the window's inner width and inner height, create a canvas element, and then append the document's body with that canvas element. Set its width and height to the entire window. So this entire thing is a canvas element. We actually don't need this yet. Then I've got this animate method, which is continually looping, and I'm clearing the screen every frame and then calling that method again. No, right now I'm not drawing anything at all. Why don't we draw something? So I'll start with a single particle, then add a bunch of particles. Function get particle, and it's going to return this particle, which has an update method. It also has a render method. Inside of here, let's define those methods. This update method is just going to move the particle along. Right now, we'll just say nothing. And then the render method looks like this. It's going to say, we need to pass that render method the context that we're creating. Let's just render it first. Particle dot render. Okay, we're going to pass that context. If I save it now, nothing happens because I'm not really doing anything at all. But I want to do something. I'm going to say context dot fill style, and I'm going to give this an RGBA 255. So it's a fully opaque white thing. So context dot begin path. Then I'm going to arc, and it takes an X and a Y number, a radius, start angle, end angle. Screen width times 0.5, screen height times 0.5, radius 10. Start angle 0, end angle, math.pi times 2, and then we're done there. And the last thing we're going to do, c.fill. So now I've got my first particle here. I want to pull this position info out here. And whoops, didn't mean to do that. Let's say screen height, and that's going to be Y. Now I can just pass that in as X and Y. Same result, no big deal, but I could easily update X and Y now. Say X plus equals velocity.x, whoops, and Y plus equals velocity.y, and we'll define the velocity. Let vel equal an object with an X and Y properties, math.random times 2, whoops, and duplicate that to be Y. So now I've got a random velocity, and I'm not calling the update method, so let's call that update. And there you go. With each loop of this animation, if I save it, it'll have a different random velocity. I'm clearing the screen and updating and animating my particle. Okay. And we could change its color to be purple. We could change its radius to be very large, like that. Okay. So that's get particle. Let's get a bunch of particles.
I'd like to thank Exponent. Click the link in the description to enjoy a 20% discount on their subscription today.
I'm going to get rid of this particle here and change it. I'm going to create an emitter instead. So const emitter equals get emitter. Okay. That get emitter function returns an object with an update method. That's it. Simple. And inside of it, our emitter has an update function. I think that's going to take us up a param, but we don't have to define that yet. I want to have a couple of properties. One of them is, and my max particles, let max particles equal, start with 100 particles max first. In our update method, we're going to emit a particle and then update its position. I guess that means create a particle and then update it. We're also going to check and see if we've got more particles than our max and then remove those particles. There's two parts to this. There's particles dot for each update that particle, should be p dot update, and p dot render. And we want to pass in that context. The reason I'm passing the context in, even though it at this point is global, so I actually don't need to pass it here. This render method has access to that. I'm passing it in case we want to break this out later. It's a good practice to kind of keep it decoupled by handing it what it needs instead of relying on global variables. Great. So there's that. This is going to update the position and render each of the particles that already exist. Let particle equal get particle. Particles done push particle. I think that's enough, except we're not removing the max particles. Let's do that. And that looks like this. While particles dot length is greater than max particles, do this thing here, which is particles dot shift. Okay. Then we get a little context here. It removes the first element from the array and returns it. So how does that look? Oh, my particles are way too giant. Let's make them smaller so we can kind of see them more clearly. Cool. Let's make them even smaller. All right, they're all coming out in one direction. That's because when I defined the random velocity, I made it always positive. So let's make it sometimes positive, sometimes negative. Cool. And 100 isn't quite enough. Let's make it 500. And then those particles can live a little bit longer and really expand out like that. Cool. And then you see them kind of pop off. What I'd like to see happen is I'd like to see those particles fade as they fly away from the center. Okay? And I also want to see them leave trails. We'll start with the fade, and then we'll finish up with the trails. Okay, so let's say let fade rate equal 0.05. And then inside our update method, we need to define alpha. We'll say alpha minus equals fade rate. Okay, and then here, I'm going to change this fill style from a string to an interpolated string, which allows us to jam a variable into the middle of it, and that'll just become part of the string. Okay, and let's define our alpha as well. Alpha equal 1.0. Good. So now that's way too fast. How about 10 times slower than that? Cool. We see the particles created, then they slowly move away and slowly fade as they move further. We could slow that fade rate down even a little bit more and make the particles ever so slightly bigger. They're 2 right now. Let's make them a 3. Cool. And as they move out, they kind of fade like so. Let's create trails. To do that, I'm not going to clear each time. Instead, I'm going to fill. Okay, and I need to define the fill style. I'll do that the same as I did here, but I don't need an interpolated string. I'll just use a regular string. And the alpha will be something very small, like let's start with that. And this needs to be black. Sorry, C isn't defined here. It needs to be context. Good. Now, isn't that something? I think 0.1 is a little bit too small of a setting, but it sure does look cool. You'll notice that it's leaving a kind of permanent impression, although faded. And that impression is kind of in a square shape. And that's because of how we're defining the random velocity. If we wanted to get a nice circle, we could change that definition. Instead of a random value here, let's do this. Let's create an angle. And that angle will be a value between math dot random times math dot pi times 2. So a complete circle anywhere along a circle. And then instead of using random here, we'll just say cosine angle and sine angle. And now instead of a kind of square shape, and I also want to make that, I'll fade a little bit more. Now the particles move along a circle, so to speak, because of the way I've defined the angle instead of a square. And I also they fade out a little bit faster. Their trails fade out a little faster this time. Isn't that nice? My computer's chugging a little bit, but still, overall looks pretty smooth and pretty nice. I could increase the speed. Let's say the velocity, we could set like a scalar, so to speak, a single value to represent the speed, and then we can control it with one number. So let speed equal 2.0. Now the particles move a little bit faster. If we made it 5, it'd be more noticeable. They also travel further before they fade out, so we could increase the fade rate so they fade out sooner. It's still a little bit too slow. I want them to fade before they reach the edge of the browser window. Kind of like that. I don't like the character of the line now, though, so I want to slow the speed down. In fact, how about math.random times some number, like 2, and give it a minimum speed of 1 and its maximum speed of 1 plus 2.
To add to that, some noise effects and some color as well. To do that, is very, very straightforward. We're going to include this little script here, this function to get curl, which is for curl noise. The curl noise is described in more detail in this great post by Keith Peters on his website, bit101.com. Recommended reading. In fact, in general, I recommend Keith Peters' blog for clear descriptions of computer graphics ideas. Check it out. Okay, back to our particles. Now I'm going to import that get curl from the project. This code's up on GitHub. The library's already in there. And I'm going to uncomment this line here where I'm passing in the X and Y position of the particle multiplied by this scale here. You'll see what that it does in a second. And then I'm going to add that to the particle's velocity. Actually, the particle's position. Sorry. I could add it to the velocity, but I'm going to add it to the position. And it looks a little something like this. Isn't that nice? You can see a little bit better what's going on if I were to comment out the velocity for each particle. Now, they're only influenced by that curl. And you can kind of see what that looks like. It looks like a noodle kind of floating around. All the particles have 0 velocity. The only thing that's moving them is this value for curl. If I increase the noise force to 10, now it kind of blows them around a little bit more. And because I'm only partially erasing the particles, you can see their trails, and it leaves this really cool effect. Kind of looks like smoke or something like that. Let's add the velocity back in and reduce that noise force. All right. So you can play around with these values like the noise scale. This noise scale is inversely proportional to the effect it'll have on the screen. If I make it larger, like 0.1, it causes the particles to vibrate much more frequently. 10 times slower, 0.1, and you could see they're kind of wiggling and with bigger waves. And I like it here. So there's these nice big arcs. And I already showed you noise force. If I reduce noise force to 0, it has 0 effect on the particles. Increase it to 100 and it completely obliterates them. Leave it at 1 for now. All right, the next thing I want to do is to affect the color of the particles. I'm already kind of setting the color down here, but we're not seeing it because they're drawn at maximum lightness, and that just kind of blows away all the color. If I make that color, the lightness fade out over time, then that color is revealed. In this case, a hue of 0 out of 360 degrees, 0 is red. If I change that to 180 degrees, what is that, cyan? And I guess 90 degrees is like yellow or green or something. Cool. So you get the idea, I hope. What I want to do is to see that change over time, though. One way to do that would be to just use this t value. As you recall, each particle in the animate loop is being updated with this time value, and that time value, in this case, I'm using to determine what hue it gets. But we can also use the curl noise to influence that. Let's say curl.x, whoops, times 90. And you see the color kind of shifting over time, but not moving through the spectrum in a linear way, kind of as the way it was this moment ago. But because it's a curl noise, it's kind of moving around in a less predictable way. It's not just cycling through the rainbow of colors, but kind of jumping around in there. Yeah. You could play around with increasing this value, this multiplier here, to 360, and then you'll get a lot more colors. Heck, make it 720, and it'll be like confetti. Colors constantly shifting and changing. I kind of like it around 90. Okay. You could apply that noise to the lightness value or the alpha value. I suppose you could apply it to the velocity as well. Play around with both of those things. As always, thanks, and I'll see you next time.